Welcome to our video here on writing complex conjugates. We are going to be talking about, first off, what an imaginary unit is. Complex numbers, remember, use the imaginary numbers here. An imaginary unit, the symbol for it is an I, a lowercase I, and a lot of times if you see it typed, it'll be italicized. I always, I write it with the little leg on the bottom of it. It's just a habit. I write my T's like that so they don't look like plus signs. Okay, an imaginary unit. So I is equal to the square root of -1. And typically up until this point, you've always thought that having the square root of a negative number is always has been something that you've steered away from up until now. And so if we use our algebra skills here, and we say if we have I is equal to the square root of -1, but let's square the left side and square the right side, well, I squared is just I squared. And what is the squaring of a square root? They cancel each other out, leaving you with -1, which is what we have here. I squared is equal to -1. So both of these you should be familiar with. I is equal to the square root of -1. I squared is equal to -1. A complex number in standard form is going to be like this: a plus bi, where a and b are real numbers. They are allowed to be a is allowed to be 0. Typically, b isn't 0 because then it wouldn't be a complex number. So, if we look there, here's one example, and here's the second example. That would be a complex number in standard form. Okay, a complex conjugate. What is the complex conjugate of that? Well, if we look here, let's go back one more slide. And I'm not going to talk about standard form right now. I'm going to talk about complex conjugates. The complex conjugate of a plus bi is a minus bi. Complex conjugate of 2 plus 5i is 2 minus 5i. And I'm pretty sure that you could probably figure this one out, right? -8 minus 4i. Those are complex conjugates. So, coming here, what is the complex conjugate of 7 plus the square root of -8? Well, first off, we have to take the square root of -8 and change it to simplify that radical. Let's simplify that. Well, what three numbers multiply to get -8? Square root of -1 times the square root of 4 times the square root of 2. I picked the square root of -1 because what is that? That is I. What's the square root of 4? That's 2. And what's the square root of 2? We can't do anything with it. That's the square root of 2. And so now, let's go ahead and send this up here. Now we have 7 plus 2i square root of 2. You notice I've taken 2i and the square root of 2, and I've put it right there. So there we go. I'm going to erase this here, simplifying the radical. At least I thought I was going to. And there we go. And the complex conjugate of it, you just basically there's a complex conjugate. All right. Now these ones here are a little bit different, but not much. The issue is we don't want to have the complex number on the bottom. And so how can we do that? Well, what we're going to do is, here's the fraction that we're given, and we are going to multiply it by the complex conjugate on bottom and the complex conjugate on top. because essentially, what is this number here? That number there is equal to 1. So if we multiply this by 1, we still get that same number. It just looks different once we get the multiplication done. So distribute 2i plus 6. And now we have a binomial times a binomial. We are supposed to FOIL. I times I squared. That should be ringing a bell for you. I squared is equal to something. I times 3 is 3i. And now here, negative 3 times I, negative 3i, and negative 3 times positive 3, which should be negative 9. So now, what I would like to do is I'd like to combine like terms on the bottom. 3i and negative 3i make 0i, which is just 0. I squared is equal to negative 1. Go back and check your notes. And then we drop down negative 9. What is negative 1 minus 9? I believe it's negative 10. And then we have 2i plus 6 on top. Now let's remember that this is not in standard form. We do want to put it in standard form. So we just separate it. 2i over 10 and 2i over 10. 10 was negative, so we put the negative sign out there. And then if we have a positive 6 divided by negative 10, that's going to be a negative 6 over 10. And I believe you know that you're supposed to reduce. And so there we have the standard form of the complex conjugate of 2 over the difference of I and 3. Okay, let me go ahead and wrap this problem up here. I know I've circled it and I said it was finished, but it came to my attention, hit me later on, that standard form, if we go back to look at standard form, you notice how I is always last? Well, we need to go ahead and do that with this one here. Let's go ahead and put the I last. And then so that's in standard form. And there you go. That there is the final answer. Okay, there is an example there for you. I'd like you to try that one on your own. Pause the video when you're finished, or pause the video now and then try it, and then hit play and check to make sure that you are correct. What is the complex conjugate of it? So we're looking at 3 over I, 2 plus I. Alright, so we want to multiply this by 2 minus I. 2 minus I. On top, distribute, that's going to give us 6I minus 3I squared. And on bottom, I know that gives me 4. The middle terms give me negative 2I and positive 2I, which are going to cancel out. And then the last term, negative I squared. Alright, well, we know that I squared is negative 1. So we're going to plug negative 1 in here for I squared. And we're also going to plug negative 1 in here for I squared. And this becomes a plus. And so now we are left with 6I over 5. Negative 3 times negative 1 is going to be a positive 3 over a positive 5, which is a positive. And so there's the standard form of the complex conjugate of that right there. Same thing here. Let's go ahead and change this to standard form. 3/5 plus, it's not a t, it's a plus sign, and 6i over 5. And now that's in standard form. So there you have it.